All right, guys, we're back. Page 131, section 4. We're going to talk about V blocks. A V block is pretty much a block that has a V notch in it that holds up a cylinder, okay, or a pipe, okay. So this allows it to be put up and down and make sure that we get to the center line and make sure that it's a correct distance. So we're going to measure from the center of the pipe down, or the cylinder, from the pipe down to the end of our faceplate, okay. So then when we look at this, that we can see that this is a pipe because we see the hidden line, and this is our plate, okay? And we can see how it looks. Now, what tool can be used to maintain the right angle relationship between item B and the faceplate? So here's item B and the faceplate. So remember, we can use any tool that we've talked about already. So we would use an angle block. So what is the relationship between item A and the faceplate? So item A is here, and the faceplate is here, and they are parallel. And item A and B intersect each other, so that means they are perpendicular. All right, parallel bars. The best way I can explain this is that we use these in CNC machining, okay? And what they are exactly machined little blocks, okay? You can get them all the way from a 1/16 of an inch all the way to several inches, okay? And these parallel bars go underneath whatever you're working to make sure that you have an accurate distance. So as we can see, from this edge to this edge, it's 3 inches. So we're going to use 3-inch parallel bars, okay? All right, so this is a little tricky, so let's take a look at it. So it says, if I can make this word, what thickness parallel bar should be used to properly locate the center of the square tube 4 inches above the surface of the faceplate? So now let's look. Here's our faceplate, okay, and we want it to be, so this would be the end of our faceplate that comes over here. We have a center that's here, so this is 2 inches to the center and 2 inches to the side. So I would probably use a 2-inch block. And what tool can be used to locate the side plates perpendicular to the faceplate? Well, we can also use an angle block. If 1-inch parallel bars were used, the center line of the square tube would be located how many inches from the top of the side plates? And how many inches from the faceplate? Well, let me show you. Oops, too far. So remember, then this number here changes. Okay? So it says from the top of here to the bottom of here is 8 right now, right? So if we changed it to 1 inch, so this would be 1 plus 3, 8 minus 3 is 5, okay? So then it would be 5 inches from the top and 3 inches from the faceplate. Make sense? Kind of, sort of, maybe? All right. C-clamps, guys. I think you know how they work, but let's make sure that you guys understand how they use them in this context. So they're saying that this is context, or I should say C-clamp A, and it clamps down my faceplate to my piece number 1. And clamp B clamps the piece number 2 to my angle block. Okay, so what surface would be used to clamp items 1 to the faceplate? So here's item 1. And what surface would I use? I think I would use surface A because this is my faceplate, so A. What surface would be used to clamp and maintain parallel relationships between items 1 and items 2? I would think C. What tool in combination with the clamp can be used to maintain the right angle between items 2 and 3? Angle block. Okay, steel bar clamp. These are really cool, okay? And so they have, it looks like a big pipe, or sometimes it looks almost like a square. And it's not too big, but they can be as tall as I am or even larger. and we can move them to whatever size we need. We can make them push in or push out. These really help when we're trying to align something rather than try to push it. It's helpful. Okay? So here, the distance between the two vertical members is to be 34.5 plus or minus an eighth. What is the minimum and maximum dimensions between the two parts? Well, here it is. You're going to have to do 34.5 plus 1/8, 34.5 minus 1/8, and it'll give you your dimension. And then, if a sliding clamp is used, how many inches must the vertical members be moved within the desired tolerance? So you're going to take 36 minus whatever your largest desired tolerance is.